All right, here's part B. My camera went wackadoodle on me and stopped. So the last thing I said to you is 2.5 grams of copper sulfate is how many moles? So we can do the math on that. Copper's about 65. Sulfur's 32. 4 oxygens would be 64, right? Going to add all those up. Sorry, I said 65. It's 63.5. I know this. 63.5 plus 32 plus 64 gives us, we're going to call that 160. 160 grams per mole for copper sulfate. We only have 2.5 grams. So 2.5 divided by 160. You should have gotten 0.016 moles, right? Okay, so we have 0.016 moles here on our scale. And I'm going to take, I got a little beaker. And I'm going to put powder in there. And now, I'm not going to fill the powder up to a whole liter. I'm just going to put some water in there. Whoops, good Lord. I'm just going to put some water in there. Okay, I put 175 milliliters in there. 175 milliliters. So now we need to figure out how strong this is. Now, yes, Mr. Perkins, you need to put that thing on the mixer and mix it up. True that. I can do that, no problem. Here we go. Put it in the mixer. There, now it's mixed up better. All right, so here's what we're going to do. We're going to figure out how strong that solution is. And that solution strength is this. How many moles per 1 liter are equal to, remember we had 0.016? Having 0.016 moles in 0.175 liters. Does this fraction make sense? If we're going to find the molarity of the solution, we need to know it's equivalent to how many moles per 1 liter. Well, we put 0.016 moles in 0.175 liters. So very simply, we'll just math it up. We'll say 0.016 divided by 0.175, and it gives us 0.09. So this solution, if I was going to label the side of it, I would make a little sticker and I would say, the strength of this solution is 0.09 M, and then I would write CuSO4 there. Does that make sense? Let's get you to try one. We're going to go back to table salt, NaCl. I'm going to put, so we're talking about NaCl. Now I'm going to put some on the scale. Let's try to come up with a nice even number. So I'm going to put, we're going to call it 9 grams. So I've got 9 grams of NaCl. So your next question is, here's your question. 9 grams of NaCl is equal to how many moles? Right, and of course you're going to say 9 divided by 58 grams. 9 divided by 58, we'll take our calculator. 9 divided by 58, boom. It's 0.155. I'm going to call that, well, I'm going to say 0.155. 0.155 moles. Now I'm going to take that powder, I'll take that salt, and I'm going to dump it into my beaker. And I'm going to pour some water in the beaker. Just a random amount. Okay. Whoops. Sorry about that. Now let's see. I have put right at, I'm going to make it exact. Whoa! We'll make it exact. There we go. I'll put 200 milliliters of water in here. There's 200 mil. I know you can't read it, but it's hard for me to turn it sideways for you. 200 milliliters of water. So I've put 0.155 moles in 0.2 liters of water. You tell me what the molarity of this saltwater solution is. What is the molarity? All right, that's easy. How strong is that solution? You're going to say 0.155 divided by 0.2 is equal to x over 1. So 1 times 0.155 divided by 0.2. The answer is 0.78. So this is 0.78 molar NaCl. And I would make that a little sticker. And then I would stick it on the side of this glass. And if I left it in the chemistry lab, someone could pick it up and say, ooh, I know exactly how salty this water is, all right? So it's time for you to try some. The next problem is, what if I put 13 grams of Na3PO4 in 500 milliliters of water? Okay? That would be a blank molar solution. You're going to say 13 divided by 164 grams equals how many moles equals how many moles? So 13 divided by 164 is 0.08. So you have 0.08 moles. And now the question is, if you put 0.08 moles in 0.5 liters of water, because that's what 500 milliliters is, that will be equal to how many moles per 1 liter? Because this is what molarity is. Molarity is how many moles per liter. So you would solve that, and you'd have 1 times 0.08 divided by 0.5. 0.08 divided by 0.5. That would be a 0.16 molar solution. 0.16 molar Na3PO4. All right. Let's do another one. What if you put 4 grams of sodium hydroxide in 300 milliliters of water? Okay? Now this time I'm just going to tell you the steps and you do them. First thing you're going to do, you're going to convert that to moles. And you're going to figure out how many moles that is. And you have that many moles in 300 milliliters. And then you're going to say that will be equal to how many moles in 1,000 milliliters, or how many moles per liter. So I'm going to work it now. 4 divided by 40 is 0.1 moles, because this weighs 40. You have 0.1 moles and 0.3 liters. That's equal to how many moles per liter? And that's going to be, off the top of my head, 0.33 molar. That would be 0.33 molar NaOH. Here's the last one. I'm going to give you 0 help on it before I ask you the question. You put 12 grams of calcium chloride, CaClO2, and you put that in 750 milliliters of water. How strong would that be? It would be blank molar CaCl2. I'm going to ask you now, giving you 0 help. All right, here's the solution. CaCl2, the weight of that is 111 grams. So you're going to say 12 grams divided by 111 grams means I have 12 divided by 111 equals, I have 0.11 molar, 0.11 moles, excuse me, I have 0.11 moles. I have 0.11 moles in 0.75 liters, and that would be equal to how many moles per 1 liter? That gives me 0.11 divided by 0.75, and that would be 0.15 molar. So that would be 0.15 molar CaCl2 if you made that solution. You make a sticker like this, and then you would put it on the side of the beaker. I hope this helps. And peace out from the Dirt Bike Shed.